graph. Have you started? The graph below is the velocity time graph. Is the velocity time graph of the motion of a car. Calculate the acceleration of the car. Calculate the acceleration of the car. So the horizontal component is measured in time. Time is plotted on the horizontal component, which is, let's say, it's seconds. And the vertical component, you have velocity, which has an SI unit meters per second. Okay. Here is 15. This point you're having 0, which is the origin. Over here you have 5. Here you have 10. Here you have 2 seconds. You have 4 seconds. You have 6. And then you have 8. You have 8 seconds here. This is time, seconds. Okay. Now, what are the options given to us? The options: A, you have 15.00 meters per second square. B, you have 7.50 meters per second square. C, you have 3.75 meters per second square. D, you have 1.86 meters per second square. Then finally E, you'll be having a 1.50 meters per second square. Let's solve that question. The graph below is the velocity time graph of the motion of a car. We are told to calculate the acceleration of the car. Now, a velocity time graph is a graph that shows the components of velocity plotted against time. Now, velocity is always plotted on the y-axis, or you can call it the vertical component, or you can call it the ordinates. And the time is always plotted on the x-axis, or you can call it the horizontal component or the abscissa. So you see that the values of velocity is plotted here, ranging from 0, and then you get to 5, 10, and 15. 15 is the maximum velocity. And the values of time is plotted here. You have 0, 2, 4, 6, 8. 8 is the maximum time taken for that motion of the car. Now we have to obtain the acceleration. Now one thing you should know is that the distance from here to here, this slope or the gradient shows you the uniform acceleration. It shows us the uniform acceleration. It shows us uniform acceleration. And this component shows us the constant speed, constant or uniform speed. And then finally, this component shows us the uniform deceleration. Uniform deceleration. Deceleration is also known as retardation. Retardation. And that word there, retard, means to come to rest. So retardation is a negative form of acceleration. That is the decrease in velocity with respect to time. So it is negative, whereas uniform acceleration is always positive. Now, we'll take this component. If you say here is O, you can call here A, you can call here B. Now take triangle OAB. OAB from triangle solution from triangle OAB. If you take this component OAB, you'll be having you have something like this: O, A, and B. All right. Now at this point A, you have 15. and at point B here, you're having 0. That is final velocity v2 and initial velocity v1. Okay? Now, at point O here, you have time as 0, and at point B, the time is what? 2. This is it. At point B, time is 2. So this is 2. So you call this T1 times T1 and there times 2, 2. Now we are trying to obtain this slope. We are trying to obtain the slope or the gradient. Gradient gradient OA. This is what we are trying to obtain, which is the uniform acceleration. Now here becomes the change in time. And here becomes change in velocity. Change in velocity is the final velocity minus initial velocity. Change in time is final time minus initial time. Alright, so the slope OA is equals to what? Vertical component AB over horizontal component OB. Vertical component AB over horizontal component OB, which is this is A. A equals to what? Change in velocity over what? Change in time. Alright, so that is it. So this slope or the gradient becomes what? The change in velocity over change in time, which is the slope of any straight line graph like this is the vertical component divided by the horizontal component. Alright, so this will be this then becomes A will be equals to V2 minus V1 over T2 minus T1. And the value of V2 here, which is the maximum velocity, is 15. 15 minus the initial velocity here is what? 0. 0 over T2 is what? 2. And T1 is what? 0. So A will be equals to 15 minus 0 gives us what? 15. And 2 minus 0 is what? 2. Now, 15 divided by 2 is 7.5 meters per second square. 7.5 meters per second square. And that is option what? Option B is the answer. B is the answer. That is the uniform acceleration is 7.5 meters per second square. So we have obtained the acceleration from this component. Now, if peradventure you are asked to obtain the deceleration or the retardation, how do you obtain it? The retardation is obtained from this component. Of course, I showed you here from the diagram that the uniform deceleration is this. It shows that the body is coming down to rest. And the uniform acceleration is this. It shows that it's going upwards. So now, to obtain the deceleration, you just take this diagram, this portion of the diagram out. So if you call here OAB, you can call here C, you can call here D, you can call here E. So how do you obtain the retardation now? The retardation then becomes, to obtain the retardation, or the uniform deceleration, say from triangle CDE. Okay, so we are going to take that component out. That is what we are doing now. This is it. CDE. Here is 15. And over here you have a 0. Here is 8. And here you have a 6. Alright, so this is, like I said previously, deceleration must be negative. Now, how do you make this negative? This is V2 and V1. And then here will be T2 and T1. So change in time becomes what? T2 minus T1. And the change in velocity equals to V2 minus V1. Yeah. So delta V is final velocity minus initial velocity, and delta T is the final time minus initial time. Alright, let's do justice to that. Now what we are looking for is the gradient CE. The gradient or the slope CE. And it must be negative. So it then means that slope slope CE equals to vertical component CD over horizontal component DE. Alright, which is A will be equals to delta V over delta T. So A becomes A becomes V2 minus V1 over T2 minus T1. And what is V2 in this case? V2 is 15. It's 15 and V1 is 0. V2 is 15, V1 is 0. So you have 0 there over T2 is 6. T2 is 6. And T1 is 8. So A will be equals to 15 divided 6 minus 8 is what? Minus 2. So that will be 15 divided by minus 2 will give you minus 7.5 meters per second square. So like I said earlier, retardation or deceleration is always negative. It's always negative because it shows you what? A decrease. You see the slope is coming downwards. It shows you a decrease in velocity with respect to time. But acceleration is positive. It shows you an increase in velocity with respect to time. So that is it. This is what we must know. Alright, so we'll come to the end of the lesson for today. Thank you. Please subscribe to this channel for more videos. Thank you.